Class 12th, chapter number 6, applications of derivative, lecture number 6 homework and lecture number 7. So today we will discuss some homework questions on exercise 6.4 and we'll do other questions also as classwork questions. So starting with exercise 6.4, the first question that I'm going to discuss is first question, third part. In the third part, we have to calculate the value of under root 0.6. We have to find the approximate value of 0.6 using differentials. So again we see the function is of the form y equals under root of x, where x is 0.64 and delta x is minus 0.04. Now most of you would have been trying it to do like 1 minus 0.4, right? But what we have to do is the delta x, which is change in x, should be very small as we can write. So we'll take this value, not this one. You will get the answer from that also, but this will be more approximate answer. Now solving it, we will write first of all y equals under root of x value is 0.64, right? So we get y is equal to 0.64 is the square of 0.8. Now we will find out dy by dx. Finding dy by dx, we get from here, just see, it is x to the power half 1 upon 2 under root of x. Clear? Now 1 upon 2 multiplied with under root of x, that means under root of 0.64. So you will just mention the value here 0.64. Solving it, you get 1 upon 2 multiplied with 0.8. You will get 1 upon 1.6. This is what dy by dx. Now we will solve delta y. How do we calculate a delta y? We have to use the formula that we discussed yesterday. It is dy by dx multiplied with delta x. Dy by dx is coming as 1 upon 1.6 multiplied with delta x is minus 0.04. Now we will solve it. We will get minus 0.025. Now we know delta y, we know y, so the answer will be y plus delta y. Y is 0.8, delta y is minus of 0.025. Solving it, we get 0.775. So this will be the answer for question number 1, third part. Clear? The next question is question number 8, that means part 8 of question number 1, which is to solve 255 to the power 1 divided by 4. Whenever we have fractional powers, we try to remove the denominator of the fractional power. Now 255, can you see a number which is to the power 4 of something? Like we can write 4 to the power 4 is 256. So we can write 255 as 256 minus 1, where x will be equal to 256 and delta x will be equal to minus of 1. Now the function is of the form y equals x to the power 1 by 4. We will find dy by dx. Just look carefully. We will have 1 divided by 4, x to the power 1 by 4 minus 1. So you will have 1 divided by 4, x to the power minus 3 by 4 will come, which will be 3 by 4 in the denominator. Now we can calculate y and dy by dx as well. Let us first solve this. Okay, this implies what? That y equals 256 to the power 1 by 4. And we know this can be further written as 4 to the power 4 whole power as 1 by 4. So the answer will be for y it is 4 only. Clear? Now finding dy by dx, we will write 1 upon 4 multiplied with x to the power 1 by 4 whole power as 3 we can write. Now we just have solved x to the power 1 by 4, which is giving us 4 as the answer. So we will write 1 by 4 multiplied with 4 to the power 3. We get 1 upon 256. So we got dy by dx, we got y also. Only thing left is delta y. To find delta y, how we will solve? We know the formula. Dy by dx multiplied with delta x. Right, dy by dx is 1 upon 256, delta x is minus 1. So we get minus 1 upon 256. Now we have to find out y plus delta y. That means with respect to x, the small change in y. So y value is 4 and delta y value is minus 1 upon 256. Solving it, we get 3.9961 approximately. So this will be the answer for 255 to the power 1 divided by 4. Let us go to another question now. So now I am going to discuss 10th part of it. Question number 1, 10th part, in which it was asked to find out value of 401 to the power half. Now we should think of a square number. As we see in the fraction, the denominator is 2. So 400 is a square of 20. So we can break it as 400 plus 1. This will be x and this will be delta x. Right. Now we will find y. Y equals x to the power half. So from here we can directly calculate x to the power x. X is 400 to the power half. Now 400 can be written as square of 20. And we get the answer for y is equal to 20. So we go to y. Now to find out dy by dx, we have x to the power half. Differentiating it, we get 1 by 2 under root x. 1 upon 2 under root x we have just solved, it will be 20. So we get 1 upon 40. Now the only thing left is delta x. Right? Delta x we have, the only thing is to calculate is delta y. To calculate delta y, we will write dy by dx multiplied with delta x. Delta x is 1, dy by dx is 1 upon 40. Now what we have to calculate is y plus delta y. Y is 20 plus delta y is 1 upon 40. So we will write 20 plus 0.025. Adding it, we get 20.025, which is the value for y plus delta y. This is how you are going to solve question number 10th or 10th part of question number 1. Now we will discuss 11th part of the question. 11th part is 0.0037 to the power 1 upon 2. Right. Now we should think of a square, and the nearest square to it is 0.0036. It is a square of 0.06. Now if we add in it 0.0001, we get 0.0037. So this will be x and this will be delta x. Right. So now we will write y is equal to x to the power half. So y is equal to x is what? 0.0036 to the power half, which will come out to be 0.06. Now dy by dx will be 1 upon 2 under root of x, and under root of x we just have solved here. It is 0.1 upon 2 into 0.06. Right. So now we will get 1 upon 0.12. Now we will find out delta y. To calculate the change in y, we will write delta y is dy by dx multiplied with delta x. So dy by dx is 1 upon 0.12 multiplied with delta x is 0.0001. Solving it, we get 1 upon 1200, which is in decimal, if we write, will be equal to 0.00083. So we have calculated delta y also. Now we will find y plus delta y. Y is 0.06 plus 0.00083. Adding this, we will get 0.0608 approximately. So this will be the answer for question number first 11th part. Now let us discuss the another part. We'll discuss 14th part of question number 1. So in 14th part of question number 1, it is asked to solve 3.968 to the power 1 divided by 2, or it is 3 divided by 2. It's not 1 divided by 2. Now to solve this, just to see, you have 2 in the fractional power in the denominator. To remove that, you should think of a number which is very close to 3.968, and we see it is 4. Now 4 plus, what we have to do, we have to subtract something from 4 so that we get 3.968. So the number will be 0.032. So we can consider this as x and this as delta x. Now how will we find y? Y is equal to x to the power 3 by 2, right? Now y is equal to, x is what here? 4. 4 to the power 3 by 2. Now 4 can be written as a square of 2 and its whole power is 3 by 2. So we get 2 to the power 3, hence y is equal to 8. Now we have got y, we will find out dy by dx. To find out dy by dx, what we will do is differentiate y equals x to the power 3 by 2. So we get dy by dx equals 3 by 2 x to the power 3 by 2 minus 1 is 1 by 2. So this is what we are getting, 3 by 2 into square root of x. X is what? 4. 4 to the power half, that means square root of 4 will be 2 only. So solving it, we get dy by dx as 3. Now the last thing to calculate is delta y. To calculate delta y, we will write dy by dx multiplied with delta x. Dy by dx is 3 multiplied with delta x minus 0.032. Multiplying it, we will get 0.096 with a minus sign in front. Now we have found out delta y and we have y also. So y plus delta y will be 8 minus 0.096. Solving it, we get 7.904. So this is the approximate value of this number given in the question number 14th or first question 14th part. Now let us discuss the last part of question number 1, which is part number 15. So in 15th part we have to find out 32.15. Whole power is given as 1 upon 5. Now we have to look for a number which is to the power 5 of some number, so that we can cancel this 5 which is there in the denominator in fraction. So we see that is 32, which can be written as 2 to the power 5 and plus 0.15. So 32 will become x and delta x will become 0.15. Now y is of the form x to the power 1 by 5. We will find y as x is 32. 32 to the power 1 by 5. 32 is what? 2 to the power 5. Whole power is 1 upon 5. So we have y as equal to 2. Now we got y, we have to calculate y plus delta y. So we got y as equal to 2. Now we have to calculate delta y. For that purpose we first need dy by dx. So let us first find dy by dx. To find dy by dx, we'll differentiate this. So dy by dx will be equal to 1 upon 5 x to the power 1 upon 5 minus 1, which gives us 1 upon 5 x to the power 1 minus 5 will be minus 4 divided by 5, and in the denominator it can be written as 1 upon 5 x to the power 4 by 5. Now we will put x value as 32. So 32 can be written as 2 to the power 5 and it is 4 upon 5. So 5 and 5 can get cancelled. We have 1 upon 5 into 2 to the power 4 left with us. Solving it, we get 1 upon 5 multiplied with 2 to the power 4 is 16, which is 1 upon 80. Now we have got dy by dx. Let us find out delta y now. So to calculate delta y, we will solve it as dy by dx multiplied with delta x. Dy by dx is 1 upon 80 multiplied with 0.15. Solving it, we get 0.00187. Now we will put it here 0.00187. So by adding it, we get 2.00187 as the answer for question number 115th part. So this is all about your homework now, right? So let us discuss other type of questions. There are two type of questions, only one are the ones that we have now discussed, and the another questions that I am going to discuss now. In question number 3, we have to find the approximate value of f of 5.001. So see carefully, x will be 5 and delta x will be 0.001. We have been given the function as this. As in other questions, we were assuming in the first question y is equal to the number to the power something. So we consider that number as to be x. Now here this y, that is function, is given in terms of x as x cube minus 7x square plus 15. We know Just see carefully. What do we know is x plus, or let me write with y. Y plus delta y is equal to f of x plus delta x. So we can also write that f of x plus delta x minus y equals delta y. So this is something that we are going to use in all the statement question like this that have been given in the exercise 6.4. So this is what you are going to use to find out delta y. Y is what here? Y is the function itself, which is f of x, right? And delta y we will be calculating using this. Now one more thing that we can write from here is, see, y is what? F of x only. So we can also write that delta y is equal to, this is what? F of x. F of x plus delta x minus f of x, which is y itself. Clear? So this is also that we can use. It is from the same expression. See, I have written. Clear? Now we will be solving the question. We have been given the function. Let us differentiate it. Because how do we calculate delta y? Dy by dx into delta x. So f dash x will be here 3x square minus 14x. So this is what dy by dx actually. Now what is delta x? It is 0.001. So what will be delta y from here? Delta y will be 3x square, which is minus 14x, which is dy by dx, multiplied with 0.001. So this is what delta y is. Now f of x we know it, that means the y is given as x cube minus 7x square plus 15. So we have to calculate f of 5 plus 0.001, that means x plus delta x. F of x plus delta x can be calculated as y, which is f of x, x cube minus 7x square plus 15. This is y only. F of x is y. Plus delta y is this term. 3x square minus 14x multiplied with 0.001. Now instead of x, what we have the value of x as 5. We will put that value here. So 5 cube minus 7 multiplied with 5 square plus 15 plus 3 into 5 square minus 14 into 5 multiplied with 0.001. So solving it, we will get minus 34.995. This will be your answer. The only thing that you need to do in this is that you need to find out x and delta x. You have to find out the value of this. Now the formula to be used for f of x plus delta x is y, which is f of x, and delta y will be calculated as f dash x into delta x. So if I write the formula more clearly in simple terms, just see what we wrote, x plus delta x is equal to y plus delta y. Now y is what? F of x given in the function. Delta y, how do we calculate the differentiation of the function? Into delta x. So this is what we are going to follow in all the questions, like from question number 2 to question number 9. This is what you are going to follow. So just note down this formula, and it is really easy. This a change in x will definitely create a change in y. Based on that only we have calculated it. Now let us do another question of it. Now in this question number 4, we have to find the approximate change in volume. That means what is to be calculated? Delta V, right? Of a cube of side x cube. So what's the formula for volume of cube? It is x cube if x is the side, right? By increasing the side by 1%. So what will be delta x? Just consider x is the side. Delta x is 1% increase. That means 1 upon 100 of x, which is x upon 100. Also can be written as 0.01 x. So this is what delta x we have. Now how do we calculate delta v? Delta will be calculated as d by dx of v into delta x, right? As we were doing dy by dx into delta x. Now what is the formula for volume? X cube multiply by delta x. X cube will be 3x square and delta x is 0.01 x. Now when we multiply, we get 0.03 x cube. X cube is what? The original volume we have. So the change in y is 0.03 times of the volume. So the approximate change in volume v is 0.03 v. Clear? This is how you are going to write the answer for question number 4. Let us discuss another question. Question number 7. We will get 2.16 pi square meter. So the approximate change is 2.16 pi. Clear? This is how you will be solving question number 7. So I have discussed one problem of each kind from the chapter. Like I discussed question number 4, you have similar kind of question to that. We have discussed question number 7, the same type of question you have in the exercise. So it will be very easy for you to attempt the questions. Now the last question for today that I am going to discuss is question number 9 of the exercise. In question number 9, the approximate change in volume of a cube. So let us V be the volume and change in volume be represented with delta V. So we have actually to find delta V. Change in volume of cube of side x meters, side is x meters, caused by increasing the side by 3%. So what will be delta x? 3% of x, which is 0.03 x. Observe carefully, this we have done in previous last to last question. There it was just 1% change and the question is exactly same. Now how do we find a delta V? It is calculated as dV by dx multiplied with delta x. So first of all, what is the formula for volume of a cube? It is x. You will place here d by dx of x cube multiplied with 0.03 x. Now you will write it as 3x square multiplied with 0.03 x. X value, just see, now you will multiply. So just see, you have x cube at the end and you will multiply 3 and 0.03. So you have 0.09 x cube, right? This is what, and you can just write cubic meter here for the unit. So the change in volume is 0.09 x cube cubic meter, which is your third option. So this will be the correct answer. See, we have already done this kind of question and again it is revised. Now I think you can attempt the complete exercise 6.4 along with its examples. So what you are going to do these complete questions of classwork up to the question that I have discussed, and for homework you will be doing question number 3, question number 5, question number 6, 8 of exercise 6.4. Also you will complete examples of exercise 6.4. These examples are really important to do, right? And then we are going to start in the next topic a new concept of maxima and minima, which is really interesting, and that actually will tell you how to use differentiation, like what are the applications of differentiation in real life. Now after doing this, you're going to come up with doubts, and for more videos like this, do subscribe the channel Ad Quark and keep liking and sharing the videos. Thank you. Stay safe.